We now are beginning Unit 3. We move out of descriptive analytics, which was Units 1 and 2, into predictive analytics, the second broad area of the three broad areas of business analytics. And in particular, we're going to look at linear regression. Ideally, you have seen this before in your previous stats course, your Math 210 or your Math 120 course. You should have seen at least some simple linear regression. So some of this should be relatively easy for you as a review. So let's get into what we're trying to do. So we have relationships between variables. So units 1 and 2, we spent a lot of time on looking at individual variables, so a single column in a data set. This time, we are more interested in comparing or looking at relationships or associations between two different columns of the spreadsheet or data set. So, we're often interested in making managerial decisions based on the relationship between them. So we often want to predict what is going to happen. So if I change the price of a product, how will that affect sales? Will it go up? Will it go down? By how much? Things like that. So when we're concerned with only two variables, we can easily plot the data. Now we did this back in Unit 2, so you should know what type of chart that we want to use. So take a second, think about it, and I'll let you know if you get it right. So hopefully you said scatter plot. So we have an X and a Y axis, and we plot the dots as the pair of X's and Y's, right, in the coordinate plane. So then we could also, in addition to plotting the data, we could also calculate some statistics. So we talked about the correlation coefficient back in Unit 1, and it's used to determine both the strength and the direction of the linear relationship between the two variables. It's important to remember that it's a linear relationship that it's measuring. So what values can the correlation coefficient take? You should remember that it can be inclusive between -1 and +1. A +1 means that it is perfectly positively linearly correlated. So there's a perfect linear relationship to it, and it's completely strong, right? So one is the strongest it can be. We also looked at covariance back in Unit 1, the sample covariance. And we said, oh, that's good. It also measures linear relationship, but there was a disadvantage to using that instead of using the correlation coefficient. So you should recall what that advantage of using the correlation over the covariance is. Basically, the correlation coefficient doesn't matter what type of units the variables are measured in. Covariance does. So you can't tell the strength of the relationship from the outcome of the sample covariance. So to find the correlation coefficient, in Excel we use the CORREL function that's built in, standing for correlation. So we should also remember that correlation does not equal causation. Right? So even if there is a correlation between two variables, it does not mean necessarily that one is causing the other. We would like to sometimes try to confirm or verify that, but in general, correlation does not equal causation. And the direction of the relationship between the two variables is vitally important. You must get this right or you will not do well. Correlation will be the same regardless of which order you put the variables in. But if we want to start to try to use it for inference, like we're going to very shortly, then we need to know which one is the X and which one is the Y. So the Y, the variable that goes on the Y-axis, is our dependent variable, the outcome variable. And I have a nice little table here of nomenclature that is also in the textbook, of what we might call the Y variable versus what we might call the X variable. So the Y variable might be called dependent variable. It depends upon what X does. The X is the independent variable. So the external stuff that is affecting the Y. Y might be called the explained variable, and X is the explanatory variable. So X is explaining how much or how Y is reacting. Y could be the response variable, X could be the control variable, and then Y could also be the predicted variable, and X is the predictor variable. And then we have regressand and regressor for Y and X. So those are different nomenclatures you might come across in other classes. I try to stick with, like, a lot of times I call Y the outcome or the response is generally what I try to stick with. And then a lot of times for X I use independent variable. Right?